And finally, in electrophilic addition, just a little bit on carbocations. So remember we said that a carbocation is a carbon that has a positive charge because it only has 3 single covalent bonds, when in actual fact it can have 4. So we've got 3 different types. One is a primary, one is a secondary, and one is a tertiary carbocation. If you have a primary carbocation, what that means is this carbon is only bonded to one other alkyl group, so only one other set of carbons. If you have a secondary carbocation, what that means is this carbon, that is the carbocation, is bonded to 2 alkyl groups. It is bonded to 2 other carbons. If you have a tertiary carbocation, that means that this carbon is bonded to 3 different alkyl groups. Just like we talked about primary, secondary and tertiary halogenoalkanes, you've got the exact same thing for carbocations. Right. So now thinking about, well, which one is the most stable? A carbocation has a positive charge. That positive charge has a very, very small area to spread itself over if there's only one alkyl group. So that means this positive charge can only really spread its charge over one alkyl group. As a result, this is still going to be quite positive, so it's not very stable because it can only spread it out over a smaller area. So this region is still going to be very positive. However, if you have a secondary carbocation, this positive charge can spread out over here and it can spread out over here. If it can spread out over 2 alkyl groups, this area of positivity in the middle is going to be slightly less positive. So it's going to be slightly more stable. It's not going to be as reactive because it can spread itself out. Now, if we look at this carbon over here, well, it can spread its positive charge out over this alkyl group, and this alkyl group. Because it has more alkyl groups, it means it can distribute that positive charge over a wider area. And if it can distribute it over a larger area because there are more alkyl groups, it means it will be more stable because it won't be as reactive. So that is why a tertiary carbocation is more stable than a primary carbocation. So now if we very quickly have a look at if I had something like but1ene, very quickly. All right, so we've got but1ene over here. If we have a Br to Br, partial positive, partial negative, what you'll end up forming from this is still got all of this. This doesn't change. Oops, sorry. But this Br, where could it attack? It could now attach itself onto either this carbon or it could attach itself onto this carbon. If it attached itself onto here, what you formed is a carbocation over here. And that is a primary carbocation, which you know is less stable because it's only attached to one carbon, to one alkyl group. However, if that bromine attached here instead, that first Br, that carbocation is now on the second carbon. And if it's on the second carbon, well, this carbon is now attached to one group here and one group here. So it's now become a secondary carbocation, which is more stable than a primary, meaning that this would be your intermediate rather than having the Br here. That would not happen. It may happen, but it'll be a minor product, but this will in fact be your major product.